Hello, my name is Abdul Hafiz bin Abdul Latif and my matric number is 24DTP 21F1033.
Hi, Assalamualaikum. My name is Muhammad Alif Aiman bin Saidi and my matrix number is 24ETP 21F1028.
My name is Nurhana Kaila binti Rosman. My matrix number is 24DTP 21F1045.
Hi, my name is Umi Humaira binti Omar and my matric number is 24DTP 21F1065.
The description of the gas metal arc welding and distinguished from the normal arc welding. Gas metal arc welding, also known as MIG welding, shields the welding arc with a gas such as argon or helium or even a mixture. The oxiders in the electrodes can prevent oxidation, which makes it possible to weld multiple layers. The temperatures are also relatively low and it is used for thin sheet and sections. It can easily be automated. Gas metal arc welding is a welding process in which an electric arc forms between a consumable wire electrode and the workpiece metal, which hits the workpiece metal, causing them to melt and join. Normal arc welding is the shielded metal arc welding. It is one of the simplest, oldest, and most versatile welding methods. The arc comes from a coated electrode tip being touched to the workpiece and then withdrawn to maintain the arc. The heat that is generated melts the tip, coating, and base metal, and the weld is formed out that alloy when it solidifies. Slag that is formed and protects the weld from oxidants, inclusions, and nitrogen has to be removed.
Principle of gas metal arch welding. Gas metal arch welding is a gas shielded metal arch welding process using the heat of an electric arch between a continuously fed consumable electrode wire and the material to be welded. Metal is transferred through a protected arch column of inner gas to the work. Some of the method of gas metal arch welding is: the clamp is connected to the workpiece to be joined. The welding gun is bring near the workpiece, and as the trigger is pressed, arch is produced at the tip of the welding gun. The arch produced melts the electrode wire and it gets deposited in between the two metal pieces to be joined and form a slag-free weld. The weld formed in gas metal arch welding is free from slag. It is a clean and effective process. Welding machine of gas metal arch welding. The welding machine is a DC contacts voltage machine.
Shielding gas of gas metal arc welding. Purpose of shielding gas is to protect the welding area from the contaminants in the atmosphere. Gas can be inert, reactive, or mixtures of both. Gas flow rate is between 25 until 35 cph. Argon, helium, and carbon dioxide are the main three gases used in gas of metal arc welding. Electrode of gas metal arc welding. Number 1. Electrode selection greatly influences the mechanical properties of the weld and is a key factor of welding quality. Number 2. Electrodes contain deoxiding metal such as silicon, magnesium, titanium, and aluminium in small percentage to help prevent oxygen porosity. Number 3. Depending on the process, variation, and base material being welded, the diameters of the electrode used typical range from 0.7 to 2.4 mm, but can be as less as 4 mm. Number 4. 1.14 mm short-circuiting metal transfer process.
Next is effects of polarity on the welding process. Welding polarity has influence on welding stability to some extent, but the specific relationship between welding polarity and weld quality has not been found, especially under the hyperbaric environment. Based on a hyperbaric dry welding experiment system, gas metal arch welding (GMAW), experiments with direct current electrode positive DCEP and direct current electrode negative DCEN. Operations are carried out under the ambient pressure of 0.1 MPa, 0.4 MPa, 0.7 MPa and 1.0 MPa to find the influence rule of different welding polarities on welding spatters and weld bed geometry. The effects of welding polarities on the weld bed geometry, such as the reinforcement, the weld width, and the penetration are discussed. The experimental results show that the welding spatters gradually grow in quantity and size for GMAW with DCEP, while GMAW with DCEN can produce fewer spatters comparatively with the increase of the ambient.
For the next slide is advantage and disadvantage of gas metal artwork. The advantage of gas metal artwork is no flux required, fast welding and deposition rate, increased corrosion resistance, easily automate welding, suitable for all metals including aluminium and stainless steel, least expensive and highly economic. For the disadvantage gas metal artwork is the arc is less stable, generates more speed, limited to short circuit, mode of metal transfer, relatively high heat and light generation, equipment is quite complex, not suitable for base metal contamination.
Description of gas tungsten arc welding and distinguishes it from the normal arc welding. Gas tungsten arc welding is also known as TIG, stand for tungsten insert gas. It uses tungsten electrode as one pole of the arc in order to create the required heat. The gas is argon, helium, or a mixture of those two. Filter wire provide the molten material if it is necessary. This process is good for thin material, and the filter wire are similar in composition to whatever is being welded. Normal arc welding is the shielded metal arc welding. It is one of the simple, oldest, and most versatile welding method. The arc comes from the cold electrode tip being touched to the workpiece and then withdrawn to maintain the arc. The heat that is generated melts the tip coating and base metal, and the weld is formed out of the alloy when it solidifies. Cell that is formed and protect the weld from oxide. In conclusion, nitrate has to be removed after very fast. This is commonly used in pipeline work, shipbuilding, and construction. Principle of gas tungsten arc welding and method of welding. The tungsten arc process is being employed widely for the precision joining of critical components which require controlled heat input. The small instant heat source provided by the tungsten arc is ideally suited to control melting of the material. In this torch, the electrode is attached via the shielding gas nozzle. The arc is ignited by high voltage, high frequency pulse, or by touching the electrode to the workpiece and withdrawing to initiated the arc at the preset level of current. Selection of electrode composition and size is not completely independent and must be considered in relation to big operating mode and the current level. Electrode for DC welding are pure tungsten or tungsten with 1 or 2% thorium. The thorium being added to improve electromission with facilities easy are ignited. Last one, in AC welding, where the electrode must operate at a higher temperature, a pure tension or tension zirconia electrode is preferred as the rate of tension loss is somewhat lesser than with thorium electrode, and the zirconia aid retention of the belt tip. Welding machine. A water-cooled welding torch is used when cooling from the insert gas sheet is inadequate.
Shielding gas of gas tungsten arc welding. The normal gas for TIG welding is argon AR. Helium He can be added to increase penetration and fluidity of the weld pool. Argon or argon-helium mixtures can be used for welding all grades. In some cases, nitrogen N2 and or hydrogen H2 can be added in order to achieve special properties. For instance, the addition of hydrogen gives a similar but much stronger effect as adding helium. However, hydrogen additions should not be used for welding martensitic, ferritic, or duplex grades. Alternatively, if nitrogen is added, the wet deposit properties of nitrogen alloy grades can be improved. Oxidizing additions are not used because these destroy the tungsten electrode. Recommendation for shielding gases used in TIG welding of different stainless steels are given in the table. For plasma arc welding, the gas types with hydrogen addition in the table are mostly used as plasma gas and pure argon as shielding gas. Electrode of gas tungsten arc welding. Tungsten electrodes are available in different diameters from 0.5 to 8 mm. The most frequently used dimensions for TIG welding electrodes are 1.6, 2.4, 3.2, and 4 mm. The diameter of the electrode is chosen on basis of the current intensity, which type of electrode they prefer, and whether it is alternating or direct current. Types of current to weld. Alternating current. Alternating current is characterized by the fact that the voltage changes polarity a certain number of times, usually 100 times per second. The electrode has positive polarity in a semi-period, and in the same semi-period the workpiece is negative. In the next semi-period, the polarity is reversed, which means that the heat energy distributes with 50% on the electrode and 50% on the workpiece. Polarity of gas tungsten are welding. Direct current straight polarity. This polarity doesn't provide a good cleaning of the surface outside, but it allows to have a good penetration since most of the heat is concentrated on the positive electrode following the impact of the electron. This polarity can be used in the following situation: massive or thick parts and where the outside unstable. High thermal conductivity metals like copper, where the thermal loss can be compensated while keeping a stable and hot arc. However, since there is no cleaning effect with this polarity, it will however be necessary to proceed to a good mechanical cleaning of the surface before welding. Direct current, reverse polarity DC plus DCEP, most of the heat is concentrated on the electrode, positive electrode and not on the part. This polarity is used for the welding of the thin sections where the penetration is not really an important factor versus of the importance to avoid the deformation and the burning of the plate. So, in that case, it is recommended to maintain a short arc to reduce the welding energy and in the same way the distortion tendency. For this type of polarity, the positive ions of the ionized gas are accelerated of the base metal negative electrode, where the impact will exercise a triple effect in fragmenting the surface oxide layer. The scoring effect happens piece by piece and is simultaneously excited by the electron issued from the subsurface, which is just under of the oxide film. The effect from the latter is to evacuate and disperse this oxide once fragmented by the gas subsurface, which is just under the effect in fragmenting the surface oxide layer. This scoring effect happens piece by piece and is simultaneously assisted by the electron issued from the subsurface, which is just under of the oxide film. The effect from the latter is to evacuate and disperse this oxide once fragmented by the gas ions. This polarity is effective for his cleaning effect and foremost in the case of metals and alloys with a very stable oxide layer and or a good cleaning action is necessary. This is the case, for example, of aluminium, magnesium, bronze, aluminium, etc. Because of the low penetration produced by this polarity, it is better to use it for the thin plate cases. Nevertheless, it is important to know that this type of polarity could cause an overheat at the level of the tungsten electrode, which could cause the function of the tip. This situation will require that we select the proper size of tungsten electrode in order to have more resistance to the overhead effect. Effect polarity on the welding process. The inert gases employed in the TIG welding are ionized under the effect of electric arc. The ionization and the expansion of these gases have a double effect: the stabilization of the electric arc and the protection of the weld wool, the base metal and the end of the filler metal against air contamination. Furthermore, the positive charge resulting from the gas ionization are accelerated and directed by the electric field towards the negative pole, cathode. Thus, depending on the electric current type and polarity in direct current, the different mechanisms in TIG welding are occurring. Direct current straight polarity, DC, DCEN.
External welding defect. First, weld crack. This is the most unwanted defect of all the other welding defect. Welding crack can be present at the surface inside of the weld material or at the heat affected zone. 2. Undercut. This is the most unwanted defect of all the other welding defect. Welding crack can be present at the surface inside of the weld material or at the heat affected zone. 3. When some metal drop as number 3, stepper. When some metal drop expelled from the weld and remains stuck to the surface, then this defect is known as stepper. Internal welding defect. First, slag inclusion. If there is any slag in the weld, then it affects affect the toughness and metal weldability of the given material. This decreases the structural performance of the weld material slightly from on the surface of the weld or between the welding turn. Second one, incomplete function. Incomplete function occurs when the welder does not accurately weld the material and the metal pre-solidifies, which lead to a gap which is not filled with the molten metal. Last one, incompletely filled groove or incomplete penetration. The defect occurs only the parts where the groove of the metal is not filled completely. It is called as incomplete penetration defect.
Combustible material source lists the following typical combustible materials and conditions: building floors, partitions, and roofs; building contents such as wood, paper, clothing, plastics, chemicals, and flammable liquids and gases; outdoor combustible materials, including dry leaves, grass, and brush; flammable gases, vapors, liquid, and dust. To prevent fires, remove combustible material from the work area, or move the work to a location well away from combustible materials. If relocating the work or materials is impossible, cover the combustible materials with fire-resistant materials. Remove or cover combustible materials within a radius of 35 feet 10 meters of the work area.
For the welding distortion in welding results from the expansion and contraction of the welding metal and adjacent base metal during the heating and cooling cycle of the welding process. Doing all welding on one side of a part will cause much more distortion than if the welding are alternated from one side to the other. During this heating and cooling cycle, manufacture affect shrinkage of the metal and lead to distortion, such as physical and mechanical properties that change as heat is applied. For example, as the temperature of the weld areas increase, yield strength, elasticity, and thermal conductivity of the steel plate decrease, while thermal expansion and specific heat increase. This change in turn affect heat flow and uniformity of heat distribution. And how to minimize the distortion is, do not overweld, use intermittent welding, use a few welding pass as possible, place weld near the neutral axis, use backstep welding.